Hello again. Welcome to the next tutorial in SEM. This time we will talk about model respecification. Thus far, we have largely dealt with unproblematic models, that is, models that work both in terms of measurement and their structural properties. Such models rarely occur in research practice, and typically any model that you may estimate may require multiple adjustments. In this tutorial, we'll consider the thorny question of model refinement and look at some additional diagnostics in AMOS that may help you improve your models. Model respecification concerns any change to your model and includes all changes to measurement. For example, changes may occur in the measurement model and may involve the removal of non-performing indicators from the latent constructs. Changes may also concern adjustments of your structural model, such as an introduction of additional relationships between your latent variables. We have seen an example of such change in our 5-construct SEM model. Why am I saying that respecification is a thorny issue? Essentially, SEM is a confirmatory technique, a technique which aims to confirm the existence of relationships based on prior theory. Most textbooks warn against modification, especially extensive modification, when using cross-sectional data. In essence, SEM allows you to demonstrate relationships between any construct that may be correlated. For example, you may correlate apple consumption with drowning statistics. Now, unless you can demonstrate a theoretical rationale that links these two, such relationships will remain spurious. Considering modifications, Hare et al., for example, warns against major changes to the model, and they consider change in more than 20% of the initial items to be a major change. They further suggest that when such major change occurs, you really need to collect new data set for further model verification. As you see, change is proportional to the model size. For example, dropping 12 items from a large battery of items is less consequential and may be less detrimental to the model. Saying that, it is important to recognize that this thinking, Hare thinking that is largely based on one strategy of estimation, a confirmatory strategy. Whilst in some instances relationships are strictly specified and the objective of your analysis is a confirmation of a relationship, in other times the relationships are only loosely recognized by pre-existing theory, and the research objective may be to discover whether they indeed exist. In fact, SEM allows for 3 different modeling strategies: confirmatory, competing models, and model development. In confirmatory modeling strategy, researcher specifies a single model and uses SEM to see how well the model fits the data. The task is to say if the model works or not. Such models are often found in published research. Competing model strategy is based on estimating and comparing alternative models. The objective here is to have an estimate of model comparison and draw conclusion as to which of the model best fits the data. Finally, model development strategy occurs when the purpose of modeling is to improve a theory through modification of the structural or measurement model. In this case, theory provides only a starting point for the development of theoretical model, and the researcher employs SEM to refine the theory. My own personal experience tallies mostly with this last approach, model development strategy. Rarely, or never if I'm being honest, do I get a model that can simply be confirmed, i.e. that works the first time round. I feel that my experience is quite common, and I suspect that a large number of articles publishing confirmatory models have in fact gone through the same model development strategy. Demands placed on authors by editors and reviewers seem to be a root cause of such practice. It does not pay to be honest, and it pays off to present your models in a confirmatory fashion. I also feel that a caution against model respecification is unrealistic, being based on a somewhat false assumption that the researchers tend to deal with reliable measures. This is often not the case in reality. For instance, you may be developing new measures and you would start at a point where you are uncertain whether the items really reflect your latent constructs. Even when you use existing scales, problems may occur. For example, previous studies may have used different data collection methods or were based on samples very different from yours. It may also be the case that measures that were marginally acceptable in previous research become unreliable in your study. This occurs, then your best line of defense is to claim a model development strategy and respecify. In addition, you might also try to emulate the distinguished authors that came before you and attempt some post-analysis rationalization. That is, obscure your starting point and the exact route you took to get here and just present your results as if you were confirming them. We have already briefly covered the notion of dropping items based on the factor loadings and adding structural paths based on modification indices. And with this very complimentary remark about academia, let's pause here before we move to the next topic, standardized residuals.